No.
No charge for protons?
Yeah.
What's the charge of protons?
Positive.
Positive.
Positive. Okay, what about neutrons? Do those have a charge?
No.
No.
No, neutrons
No,
do
man.
not have a charge. And then the last one, what about electrons? Do electrons have a charge?
Yeah.
No.
So this is what I do.
Yes, they do have a charge. What is the electron's charge?
Negative.
Negative. Perfect. And then the last couple things. Where do we find our protons and neutrons?
The center.
In the center, in the nucleus. Perfect. We find them in the nucleus, which is in the center of our atom. And then the electrons, where do we find those?
Outside.
Outside on those rings or on those orbitals. Perfect. So, couple more things. How do we change the element that we have? What subatomic particle do we have to change in order to change what element we have?
By adding protons.
Adding protons. Perfect. And if I wanted to change the mass number, if I wanted to change the mass number, what would I have to change? Or what?
Add nutrients.
The neutrons. Is there anything else I can change? If I wanted a different mass number, I could change the neutrons, or I could change what other thing?
The electron.
Protons.
The protons. So for mass number, it's protons and neutrons. And then if I wanted to change the charge of my atom, what two things would I change? If I wanted to change my charge, I could change what two things?
Protons and
The
electrons.
The protons and the electrons. Perfect. So when we're talking about those, in the simulation you guys looked at yesterday and the day before, you guys saw that the protons, the neutrons, and electrons were in a certain shape. That shape was called our Bohr model. And in our Bohr model, what happens is this guy named Niels Bohr, he created this model that of how he thought the atom looked. And he decided that's how it looked, that the electrons orbited the center of the nucleus. And for a long time, that's how it existed. If you guys saw in that simulation yesterday, it did allow you to change how the electrons were placed. It went from orbitals, and there's something else called clouds. Technically, now we know that the electrons can go anywhere in these things called electron clouds. They just kind of float around, all around. They don't have a specific circular shape the whole time, but they just kind of go wherever they want to go. And that's going to be difficult for us to draw. So instead, we're going to stick with that Bohr model. We're going to draw how the Bohr model looks instead. So on your Canvas page, there is an assignment. It's called Bohr Model Practice. What we're going to do is we're going to go through the first few together just so that we all see what's going on. I'm actually going to share my screen so that we can all see together what we're doing. So in just a second, my screen will share. All right. And now I'm going to go to, on that Bohr model practice, there's two things. There's a periodic table and there is an activity. We're going to look at the periodic table first because I want to come up with a few things. And we're going to start with hydrogen. First thing I want to know is, where's my atomic number for hydrogen?
Top left.
The top left, perfect. This right here is my atomic number. This is my atomic number. And do you guys remember what that atomic number told you? What information do you learn from the atomic number?
The mass.
Not the mass.
Dropping the album September 4th.
Which of the three subatomic particles do you know if you know the atomic number?
Protons.
The protons. This one is our number of protons. This one's going to be the number of protons that we have. And can anybody tell me where our mass number is? Where's the mass number on that hydrogen atom?
Above the H.
Where? Above the H? Is that what you said?
Yeah.
Are you saying this one right here?
Yeah.
So that one's not going to be our mass number, but our mass number is actually going to be down here. This number right here. And can you guys tell me, how do we find our mass number? What two things do we add together again? Which two subatomic particles do we add together to find our mass number? Can somebody tell me one of them?
Electron.
Not the electrons. The neutrons and
Protons.
protons. Perfect. So I'm going to put protons plus neutrons will give us that mass number. So if we know the number of protons, and what's the number of protons again? For hydrogen specifically?
1.
1, perfect. We know the number of protons is 1, and our mass number is 1.01. So that means, do we have 0.1 neutrons? Yesterday, were you able to put 0.1 neutrons of anything?
No.
No.
No. So that decimal point is because there are these things called isotopes, which we'll get to a little bit later. But isotopes, they just mean that there are multiple types of hydrogen. So hydrogen on Earth, most of them are going to have 0 neutrons because they have an atomic mass or mass number of 1. Sometimes we can have more than 1 for the atomic mass or the mass number, and that's why there's that decimal point, because they take an average of all of these other masses. So in our case, what we're going to do is we're always going to round the mass number. At least for right now, we're going to round our mass number every time. So if we round the mass number of 1.01, what are we going to round this to? If I rounded that,
1.
What is it?
1.
It just round to 1. Because if it's less than 0.5, it's going to round to 1. If it's more than 0.5, it's going to round up. So we know that there was 1 proton for hydrogen. How many neutrons do we have? If we have 1 proton and our mass
0.
number is 1, we have 0 neutrons. Perfect. How many electrons are we going to have? Remember, I want a neutral atom for these. If I want a neutral atom, that means my charge has to be 0. And if my charge is 0, how many electrons am I going to have?
1.
I'm going to have 1 electron. Perfect. And that's because we find our charge by taking the protons minus the electrons. So if we subtract our protons and electrons, they should add up to 0 for this one. So our number of protons for right now is always going to equal our number of electrons unless I tell you that I want a charge on your atom. So unless there's a charge on your atom, you're always going to put the number of protons is equal to the number of electrons. So now what we're going to do is we're going to go to the Bohr model practice worksheet. So it looks like this. And we're actually going to draw out what our Bohr model, what the atom or element hydrogen is going to look like. So we said that there was 1 proton, there were 0 neutrons, and there was 1 electron. Where do we put our protons and neutrons? We
The
said it
proton
before.
group.
In the center, in the nucleus. Perfect. Okay, so I'm going to draw a nucleus in the center of my atom. I'm just going to draw a circle. And instead of drawing little dots for the protons and labeling them and little dots for the electrons and labeling them, what I'm going to do instead is I'm just going to put a P from proton, and I'm going to write how many I have. So in my nucleus, I have 1 proton. Then I'm going to write a little N for neutron, and I'm going to put that I had 0 neutrons for the atom hydrogen. Now, my electrons. Where do my electrons go?
Outside.
Outside, on that circle, on the rings, on the orbital. So for this one, I am going to draw a dot for my electron. So I'm going to put 1 electron right here on my orbital. So I have my 1 electron, my 1 proton, and my 0 neutrons labeled. So this is how we're going to do it for all of our problems. So now what I want you guys to do is we're going to look at helium. I want you guys on your own, you don't have to say it yet, but on your own, determine the protons, neutrons, and electrons for helium. So we're going to go back to our periodic table. We'll look at helium, determine how many protons, neutrons, and electrons. In about 45 seconds, I'm going to ask you guys for answers. So make sure you guys are ready to answer that. All right, can anybody tell me how many protons we have?
2.
Awesome. Can anybody tell me how many neutrons we have?
2.
Perfect. And how many electrons do we have?
2.
Perfect. 2 of everything. So now if we go back to our Bohr model, if we're drawing this, so I'm going to write down that we have 2 of everything. What do I put down first? It's the first thing I should draw. What's the first thing I have written down? What's the first subatomic particles?
Protons.
So that's the first one I'm going to draw. And where do I put my protons?
Inside.
In the center. Perfect. So I'm going to draw my nucleus. Now I'm going to label protons. What's the next thing I should draw?
Neutrons.
Neutrons. So I'm going to put my neutrons in there too. And I have 2 of those. And then my electrons. Where do I put my electrons?
On the outside.
On the outside. So I'm going to put 1 on each side. Doesn't really matter where you put them, just as long as you have 2 of them. All right. Now, lithium. Lithium's way over here. So let's first come up with how many protons, neutrons, and electrons we'll have for lithium. I'll give you guys another 45 seconds. All right, can anybody tell me how many protons we have?
3.
Perfect. 3 protons. How many neutrons?
4.
All right, and how many electrons?
3.
Perfect. Does everybody see where we got that 4 from for our neutrons?
No.
No.
All right, so remember our mass number equals our protons plus our neutrons. And our mass number is down here. That's 6.94. And remember that we're going to round the mass number. And so if we look at 6.94, the mass number, if we round that, we're going to look at, we want to round it to a whole number. So we look at this decimal point right here to see if we're going to stay at 6 or if we need to round up to 7. And because that number is above a 5, so if it's a 5 or higher, we're going to round up to the next number. So we're going to pretend or imagine that this mass number is not 6.94 anymore, but it's really going to be 7. So we're going to round it up to 7. And that's how we took 7 minus 4 for the mass number of 7 minus 4, or minus 3, I'm sorry, for the protons to get that the number of neutrons to be 4. Does that make sense now? You good with that?
Yeah.
Okay. All right, so now that we have our protons, neutrons, and electrons, there is something else I wanted to talk about from that simulation yesterday, or the 2 days ago. So what happened, do you guys remember what happened after we went from helium when we moved on to lithium? Do you guys remember something changed in that simulation? Does anybody remember what happened? All right, let's actually take a look at that simulation. And let's see what happens. So we started with helium. And then we created lithium. So we added one more proton to make lithium. Lithium has 4 neutrons. And then lithium has 3 electrons. So I'm going to put my 3rd electron down on this ring. And what happened when I put my electron down? What happened to that 3rd electron? Where'd it go?
To the outer ring.
It went to the outer ring. So let's look at our periodic table real quick. We started with helium, and then when we moved to lithium, it went to the next ring. Why do we think that moved to the next ring? Why didn't it stay in the same ring as helium and hydrogen's electrons? What's different from hydrogen, helium, and lithium? What's the big difference you see on the periodic table?
Their atomic numbers are different.
Their atomic numbers are different. Okay. Anything else that's different? You don't even have to look at numbers. Just look at the placement. When we're looking at hydrogen, helium versus lithium, what's different?
They're in the second row.
Lithium moved to the second row. Perfect. And so when lithium moves to that second row, what happened to the electron?
They moved to the second one too.
It moved to the second orbital too. It moved to that second ring. So now before we continue going on with drawing lithium, what do you think happens once we finish neon? What do you think is going to happen with our sodium atom, with its electrons? If lithium moved to the second ring because it moved to the second row, what's going to happen to sodium when we try and draw sodium?
It will be in the 3rd row.
It would be in the 3rd row. We'll have a 3rd ring around our nucleus for the electrons. Perfect. So now going back to drawing this, we're going to remember protons, neutrons, and electrons for lithium. And we're going to go back to our Bohr model and we're going to draw this one. So by label, my protons was 3, neutrons was 4, electrons was 3. And what's the first thing I draw again?
The nucleus.
Perfect. And what do I put inside?
Protons.
Protons. And
Neutrons.
Neutrons.
perfect. And now what do I do with my electrons?
Put them outside.
Perfect. So I put 1 here and 1 here. Where does my third one go again?
The other one.
On the second ring. So I can put it anywhere on that second ring. I'm just going to put it right there. So now I have all my electrons drawn in the correct spot. Is this making some sense, guys?
Yeah.
All right. So then what I'm going to have you guys do is we did the first 3 together. I'll leave them up in case you need to copy them down because you're just paying attention or if you just want to screenshot it. But what you guys are going to do is go through